class, and today we are doing lesson 3.6, Estimating Quotients. So on page 223 in your book, I want you to fill out this chart. We have this word compatible. And I want you to tell me, what's the definition of compatible? Give me an example of something that's compatible. Tell me what might make two numbers compatible, and give me an example of something that is not compatible, a non-example, things that are not compatible. Who would like to tell me the definition of compatible? What's a good definition you have of compatible, you guys? So what's a definition you have of the word compatible? Abby, what's your definition?
I think it'd be like two compatible numbers, I think.
So she says, for example, numbers easy to, that's supposed to be an A, add, subtract, multiply, divide. So she's saying that. Jack, what do you want to say to that one?
Well, for the definition of compatible? Okay, compatible, adjective. Of two things able to exist or occur together without conflict. Noun, a computer that can use software designed for another to make or type.
Perfect. So he read the dictionary, but it still makes sense with this. So exactly, they can exist together without conflict. So that works really well with this adding, subtracting, multiplying, dividing. That means that they work really well together. They don't conflict. We're not going to get run on decimals. We're not going to get things like that. Who would like to give me an example of something that's compatible? An example of anything that's compatible? Lennox, what's an example of something that's compatible?
Something that's easy.
Well, what was an example for me? What's an example you got? Harry, what do you say to numbers? Like, give an example of numbers that are compatible.
Well, I was going to say earlier, 4 and 8.
So, for example, 4 and 8. And why?
Because you could divide them easily and multiply them easily, subtract them easily, and add them easily.
Yeah, so with compatibility, we're mostly caring about dividing. Dividing is going to make it helpful. We can multiply a lot of numbers easily as long as we know how to multiply. We can add and subtract them, but because they're both even, we know they divide easily. So what would make numbers compatible? Exactly. To be easy to divide. Basically, it'd make it to be easy to divide. And a non-example, I'm going to use Lennox's non-example though, because his was with multiplication, but 25 and 4. 25, is that divisible by 4? Is 25 divisible by 4? No, not for an even number. Not for an even number. So those don't work because 25 divided by 4 is going to give me a decimal. And I don't want decimals when I'm trying to make it easy on myself. So right below that on your page, Latasha and her two sisters want to buy their little brother a remote-controlled helicopter. The helicopter costs $28.90. They want to split the cost evenly. So there's 3 of them total, Latasha and her two sisters. They want to split the cost evenly. But I look at $28.90. Can I instantly think about what that's going to be? Do I instantly know what it's going to be divided by 3? No. So what would be a good number close to $28.90 that would be divisible by 3? What would be a good number? I want to know, Jalen, what would be a good number? Then 30. Yes, 30 is a great number to divide by 3. I can't do $28.90 in my head divided by 3. But can we do 30 divided by 3 in our head? Yeah, we can do 30 by 3 in our heads. So we see things where we know, okay, they're each approximately going to pay $10, right? They're each approximately going to pay $10. So save up $10 and you know that you'll have enough money. You know that we can cover it. I want you guys to copy this down in your books. Estimating by rounding dividends. To estimate quotients, the answers of decimals, so to answer to find the answers when we're dividing with decimals, We can use rounding with compatible numbers. So like we just did with the 30, where we rounded it to a number that's easier to mentally divide, we can do that. So compatible numbers are numbers that are easy to divide mentally. So they're numbers that are easy to divide mentally. That 2890 was not easy to divide mentally, but that 30 was. Let's look at this example. I have 11 and 75 hundredths divided by 4. Can I do that easily in my head? Can I think, okay, what is that in my head? No, I can't think of that easily in my head. I see you guys using the yes, no buttons. I love it. So what is something that I could change to make it easily divisible? Nathan, what could I change?
12.
Yeah, I could change it to a 12. 11 and 75 hundredths is almost 12 anyway. And then we think about it, 12 divided by 4, that works. On your fingers, what is 12 divided by 4? On your fingers. 3, yes. I want you to think about this one. The Jenkins family bought 5 tickets to a charity auction. The receipt shows the total cost of the tickets. So estimate the cost of each ticket and justify your answer. What we know is we want to pick a number that we can divide by 5. We want to pick a number that we can divide by 5. Ben, what would be a good number to round it to?
60.
60, yeah. 60 divided by 5. And as a lot of you guys wrote in the chat, what we get is 12. So we see that Harut wrote 12. All of these guys, so many people wrote 60. We see all of that. We know you can divide 60 by 5. Tamar wrote 65. Does that make him wrong? No. That's also close. If we divided 65 by 5, we would get 13. 12 and 13 are not that far off from one another, so we see, okay, our estimation works. Exactly. So we find out the cost of each ticket is about $12. Do we remember, if we can tell, is the ticket going to cost more than $12 or less than $12? What do we think? Is the ticket going to cost more? So I see Lennox pointing up. Yeah, the ticket's going to cost more. The reason is because this is more than 60. So the answer is going to be more than 12. So the answer is, the first part is more than 60, so the answer is going to be more than 12. I want you to do these 3 problems for me. I want you to do these 3 problems. Remember, we're estimating to make it the best that we can do easily. So let's look at this first one. What we rounded 49 and 3/10 to. Clara, what did you round 49 and 3/10 to?
I rounded it to 49.
She rounded it to 49. And 49 divided by 7, what did you get?
7.
Yes, 7. Great job. Harut, what about the next one? What did you round it to? So what did you round the 98 and 1/10 to?
100 divided by 25.
Yeah, so 100 divided by 25, and what was your answer?
4.
4. Look at that. So much easier than if we were just trying to do it straight up. Leor, what about the last one? What did you round it to? Jack, what did you round it to?
I rounded it to 66 because 66 is divisible by 6.
Yes, and Lennox, what do you get for the answer?
You get 10, but also
You don't get 10.
11.
You get 11. So perfect. Yes? Perfect. So Leor, what did you round this to? What did you do?
I rounded 10.75 to 11.
So she rounded it to 11. And then what did you get as your answer, Leor?
9.
9. Do we agree? Disagree? What do we do? We agree. Yes, that's great. Elias, what about you? What did you do?
I divided 56. I rounded 6.8 up to 7. Then divided it by 56, and I got 8.
Do we agree? Do we disagree? We agree. Yes, that's awesome. Isabella. Okay, what did you do, Isabella?
So, I rounded it to 4.
Perfect. And what'd you get?
I got 8.
Excellent work. Great job. Okay, Jonathan, what did you do?
Okay, I might get this wrong, but I rounded the I rounded the 9 and...
The 9 and 1600ths.
Yep. Into just 9.
And then what'd you get as your answer?
And I got 6.
You are completely correct. Who can tell me what numbers we're dividing? So how would I write this in order? Nathan, how would I write this in order? The initial one.
704 and 4/10 divided by 49 and 9.
Excellent. So that's the initial way of how we would write it. Josh, what are you thinking about rounding these numbers to? So he rounds 704 and 4/10 to 700. What about the other one? What do you round it to? 50. Oh no, you did so poorly. Of course you got it correct, dude. That's exactly what we do. Yes, it's exactly what we do. Edson, what do you get when you divide?
When you get?
Yeah, what do you get?
14.
14. Yes, and in the chat, we had Alina who wrote it. We had Lennox who had it. Oslin wrote it. Nathan wrote it. So we see things like that. Lennox, how do you know your answer is reasonable?
I think it was 100. Oh, no.
The one thing he did was he said, oh, I know that they both end in 0 so they can go away. And he knew that 5 times 14 was 70, or 70 divided by 5 is 4. So we know that. Yeah, so we've got that great answer. We want to round to good numbers. What about this one? There are approximately 250.9 million cars in the United States. Spain has approximately 25.1 million cars. About how many times more cars does the U.S. have than Spain? So about how many more times? Antonio, what I want you to do is I want you to set this problem up for me. I want you to set this up for me. What is the initial division for this problem? What would the initial division be?
250 divided by 25.
Perfect. So 250.9 divided by 25.1 is our initial division. That's exactly what we're doing. And then we think about good numbers to round these two. We think about good numbers. So Jade, what do you want to round these to? Oslin, what do you want to round these to?
I rounded 209/10 to 250. Oh no, 200.
Perfect. So you round it to 250. And what about the next one?
And I round the next one to 25.
And what did you get as your answer, Oslin?
10.
Yes! 10 is our answer. 10 is our answer. So we think about this. These are really good numbers. We're thinking about easy ways. So approximately, the United States has approximately 10 times as many cars as Spain. So I want you to go to the guided practice on page 226. Guided practice on page 226. Nathan, what did you estimate this to? So we did 25, he estimates 5, and what did you get as your answer?
5.
Yes! Excellent! Great job. Alina, what did you estimate this one to?
I estimated 40.79 to 42.
And then you got?
And I got 6.
Yes! This is great, you guys. You're nailing it. Excellent. Lennox, what are you going to round these to?
Round them to 1,040.
So he rounded it to 1,000, and he rounded the other one to 40. And what did you get as your answer?
So I took away the 2 zeros and I got 25.
So you took away the 2 zeros, and he got 25. Do we agree? Yeah. So we got these great ones right here. We have all of these. So now, for this one, the average yearly precipitation for Gulfport, Mississippi, is 65 3/10 inches. About how much precipitation does the area receive each month? And explain why your answer is reasonable. We don't necessarily care about why the answer is reasonable because we know it anyway. Jamal, what did you estimate to? David, what did you round these to?
Oh, I just left the 65.3.
by itself.
So you left it by itself?
Yeah, I just left it 65.
Oh, he turned it into a 65. And what are we dividing it by?
I didn't hear the problem correctly, or I didn't hear it.
Let's think about how many months are in a year. We're going to need to divide something by 12. So what's a good number that's close to there that we can divide by 12? What's a good number close to 65 and 3/10 that we can divide by 12? Clara, what is it?
60?
60, yeah. We divide it and we get 5, just like earlier. Exactly. So we don't always have to round up, round down. Our estimations, we're not necessarily following round to the nearest 10th or round to the nearest tens or round to the nearest whatever. We're just thinking of good numbers to tell us about how much we would get. About how much we would get. And if I did the actual math, I would find out that the actual answer would give me 5.4 essentially. 5 4/10 essentially. Really, really close. Jack, what about the last one? What did you round these to?
Well, I rounded 6 75/100ths to 7 and 47
$47.50.
Yeah, $47.50 to 49. So 49 divided by 7 is 7, so it costs about $7 per yard.
Excellent. It costs about $7 per yard. And again, if I were to do my actual math, if I was to do it, we would find out that it was $7.04. So that's why we do this estimation, because we find out that our answers are really, really close. So your homework is page 227, numbers 1 through 8. 227, numbers 1 through 8.